Lumbar vertebrae. The lumbar vertebrae are, in human anatomy, the 5 vertebrae between the rib cage and the pelvis. They are the largest segments of the vertebral column and are characterized by the absence of the foramen transversarium within the transverse process, since it is only found in the cervical region, and by the absence of facets on the sides of the body, as found only in the thoracic region. They are designated L1 to L5, starting at the top. The lumbar vertebrae help support the weight of the body, and permit movement. Human anatomy. General characteristics. The figure on the left depicts the general characteristics of the 1st through 4th lumbar vertebrae. The 5th vertebra contains certain peculiarities, which are detailed below. As with other vertebrae, each lumbar vertebra consists of a vertebral body and a vertebral arch. The vertebral arch, consisting of a pair of pedicles and a pair of laminae, encloses the vertebral foramen, opening, and supports 7 processes. Body. The vertebral body of each lumbar vertebra is large, wider from side to side than from front to back, and a little thicker in front than in back. It is flattened or slightly concave above and below, concave behind, and deeply constricted in front and at the sides. Arch. The pedicles are very strong, directed backward from the upper part of the vertebral body, consequently, the inferior vertebral notches are of considerable depth. The pedicles change in morphology from the upper lumbar to the lower lumbar. They increase in sagittal width from 9 mm to up to 18 mm at L5. They increase in angulation in the axial plane from 10 degrees to 20 degrees by L5. The pedicle is sometimes used as a portal of entrance into the vertebral body for fixation with pedicle screws or for placement of bone cement as with kyphoplasty or vertebraplasty. The laminae are broad, short, and strong. They form the posterior portion of the vertebral arch. In the upper lumbar region the lamina are taller than wide, but in the lower lumbar vertebra the lamina are wider than tall. The lamina connects the spinous process to the pedicles. The vertebral foramen within the arch is triangular, larger than the thoracic vertebrae, but smaller than in the cervical vertebrae. Processes. The spinous process is thick, broad, and somewhat quadrilateral. It projects backward and ends in a rough, uneven border, thickest below where it is occasionally notched. The superior and inferior articular processes are well defined, projecting respectively upward and downward from the junctions of pedicles and laminae. The facets on the superior processes are concave, and look backward and medialward. Those on the inferior are convex, and are directed forward and lateralward. The former are wider apart than the latter, since in the articulated column, the inferior articular processes are embraced by the superior processes of the subjacent vertebra. The transverse processes are long and slender. They are horizontal in the upper 3 lumbar vertebrae and incline a little upward in the lower 2. In the upper 3 vertebrae they arise from the junctions of the pedicles and laminae, but in the lower 2 they are set farther forward and spring from the pedicles and posterior parts of the vertebral bodies. They are situated in front of the articular processes instead of behind them as in the thoracic vertebrae, and are homologous with the ribs. 3 portions or tubercles can be noticed in a transverse process of a lower lumbar vertebrae: the lateral or costiform process, the mammillary process, and the accessory process. The costiform is lateral, the mammillary is superior, cranial, and the accessory is inferior, caudal. The mammillary is connected in the lumbar region with the back part of the superior articular process. The accessory process is situated at the back part of the base of the transverse process. The tallest and thickest costiform process is usually that of L5. 1st and 5th lumbar vertebrae. The 1st lumbar vertebra is level with the anterior end of the 9th rib. This level is also called the important transpyloric plane, since the pylorus of the stomach is at this level. Other important structures are also located at this level. They include fundus of the gallbladder, celiac trunk, superior mesenteric artery, termination of spinal cord, beginning of filum terminalis, renal vessels, middle suprarenal arteries, and hyla of kidneys. The 5th lumbar vertebra is characterized by its body being much deeper in front than behind, which accords with the prominence of the sacrovertebral articulation, by the smaller size of its spinous process, by the wide interval between the inferior articular processes, and by the thickness of its transverse processes, which spring from the body as well as from the pedicles. The 5th lumbar vertebra is by far the most common site of spondylolysis and spondylolisthesis. Most individuals have 5 lumbar vertebrae, while some have 4 or 6. Lumbar disorders that normally affect L5 will affect L4 or L6 in these latter individuals. Segmental movements. The range of segmental movements in a single segment is difficult to measure clinically, not only because of variations between individuals, but also because it is age and gender dependent. Furthermore, flexion and extension in the lumbar spine is the product of a combination of rotation and translation in the sagittal plane between each vertebra. Ranges of segmental movements in the lumbar spine, White and Punjabi, 1990, are, in degrees. Congenital anomalies. Congenital vertebral anomalies can cause compression of the spinal cord by deforming the vertebral canal or causing instability. Other animals. African apes have 3 and 4 lumbar vertebrae, bonobos have longer spines with an additional vertebra, and humans normally 5. This difference, and because the lumbar spines of the extinct Nacalapithecus, a Miocene hominoid with 6 lumbar vertebrae and no tail, are similar to those of early Australopithecus and early Homo, it is assumed that the chimpanzee-human last common ancestor also had a long vertebral column with a long lumbar region and that the reduction in the number of lumbar vertebrae evolved independently in each ape clade. The limited number of lumbar vertebrae in chimpanzees and gorillas result in an inability to lordose, curve, their lumbar spines, in contrast to the spines of Old World monkeys and Nacalapithecus and Proconsul, which suggests that the last common ancestor was not short-backed as previously believed. Additional images.